Welcome back to another video. So for the few videos we have been discussing multiplexer and mainly how we can use a multiplexer as a logic element. Now another combinational circuit, and it's actually a reverse of multiplexing, is known as demultiplexer. Right? So if you remember, in a multiplexer we had n data inputs and only one output line, and demultiplexer is actually the reverse. So if I define a demultiplexer, demux, it has, yeah, I can say it takes in data from one line and directs it to any of its n outputs. Fine. And कौन सा output होगा, that will depend. So depending on the status of the selection lines. Fine. So it is just the reverse of multiplexing. Multiplexing, we had n inputs which were related to the selection lines and we only had one output. But demultiplexing is the reverse. You will have only one input and your selection lines will determine this input will be routed to which of the outputs. Fine. So here is an example I have drawn here. This is a 1 cross 4 demux. It has one input line which I have denoted by I, four outputs D0, D1, D2, D3, and as usual two selection variables S1 and S0. Fine. Now we can draw a similar table and then define its function. So I actually the values on S1 and S0 will determine which of the outputs will get the input. So if I quickly make a table here, a small table, S1, S0 as selection lines, then D0, D1, D2, and D3 as my data outputs. And with two selection lines, I can have four combinations. I will list the combinations here: 0, 0, 0, 1, 1, 0, 1, 1. So if selection lines have the value S1, 0, S0, 0, in that case, output data D0 will get the input I, D1 will be 0, D2 will be 0, D3 will be 0. Fine. Then for the combination 0, 1, D1 will get the input and rest of the lines, they will be null. They won't have any value. For 1, 0, it will be D2. Similarly for 1, 1, it will be my D3. Fine. So you will have a simple Boolean expression for each of these outputs. So for D0, it will be S1 complement, S0 complement, and then it will be I corresponding to this particular output. Similarly for D1, it will be S1 complement, S0, I. Then for D2, it will be S1, S0 complement, I. Then for D3, S1, S0, I. Fine. And you can actually have a very simple gate realization. I hope you can do it. Yeah, quickly I'll make it here. So let's have we have an input line. Say the one in green is input. Then let's have the two selection lines in the order in which they appear. Let this be S1 and let this be S0. Fine. So the green one here is my input line I. This is S1, this is S0. Fine. And from here I can take tables. For example, if I have to implement D0, for D0 I will have S1 complement, so it will pass through a NOT gate, S0 complement, then they will be combined using an AND gate. So this will be my D0. Likewise D1, we have S1 complement, S0 directly, and then I, Then again using an AND gate, I will combine them. This will be my D1. For D2, S1 will be directly S0 through a NOT gate, then an input from I, and this will be my D2. Fine. Likewise, you can have D3, where S1 direct, S0 direct, I combine them using an AND gate. So this will be my D3. Fine. So this is the gate level architecture of a multiplexer. Fine. And generally in communication scenario, we have a multiplexing and a demultiplexing system. Fine. So let me see if I add a slide here. So a typical communication scenario जहाँ पे अक्सर multiplexing use होता है, it will be something like this. You will have multiplexer on one side, then you will have a demultiplexer on another side. Fine. This is from the transmitter end. Fine. So this is the transmitter. And since this is a multiplexer, so it will have multiple inputs. So I can show those multiple inputs. These are the multiple inputs. You can consider them as multiple sources. And each of these sources wants to communicate, wants to send their data through a medium, which is typically what we call a channel. Fine, so this will be my channel, the communication medium. But the problem is the bandwidth of the channel or the capacity of the channel is always limited. So these multiple sources cannot simultaneously send their data at a given instant of time. So what we do with multiplex, we use a selection variable. Okay, let me just see here. It is something like this. So these will be selection lines and they will be common. They will be common for the multiplexer side and for the demultiplexer side, something like this. So if I complete it, say this is one of the selection lines, this is another. Fine, let's call them. This is S1, S0. Fine. And then since this is a demultiplexer, it will have something like this. Fine. So the typical operation is, let's say S1, S0 is equivalent to 0, 0. Fine. Then this will communicate its data. This line will send its data. It will communicate through the channel. And since these selection lines are common to both multiplexer and demultiplexer, this data will be then sent to this output. Fine. Then if I change my these values, say S1, S0 is, let's say 1, 1. So in that case, say fourth one, this one will communicate its data through the channel. It will go through the channel and then at the receiver, it will be routed to the appropriate output. Right? So multiplexing is very important. It's a core concept that allows us to use the communication channel in a better way. Right? In the higher classes, when you read data communication and computer networks, you'll come to know about different techniques and different classifications of multiplex. So this is a typical arrangement. You'll have multiplexer at the transmitter side and you will have demultiplexer typically at the receiver side. And by using these techniques, you're actually able to use your channel in a better efficient way. Right? But as far as digital electronics is concerned, this is all about demultiplexing. It is not used to implement any logic. Multiplexer, the application in digital electronics is that it is used to implement logic, which we have been doing for the last few lectures. Right? इसमें भी आप याद रखेंगे कि the relationship, that is the number of data outputs, and it shares a relationship 2 raised power n, where n is the number of selection lines, just like we had in multiplexer. Fine, so this was about multiplexer and demultiplexer. So let's stop here.